In this video, we're going to look into the sums of infinite geometric series. So what we're really going to be looking into is a geometric series such as the following. Let's say I was trying to add up the terms of a geometric sequence that started with 1, and then let's say the common ratio was a half, where I multiplied by a half. So I'd be adding the next term, a half. Now if I multiplied that by a half, I'd get a fourth, so I'd be adding a fourth. If I multiplied that by a half, that would be an eighth. If I multiplied that by half, that'd be a 16th. And I think you get the idea. Every time I multiply by a half, I'd get another term, and I'm taking the sum, right? I'm adding all the terms together. But this goes on forever and ever, and I keep on adding on more terms. Now, intuition might tell you that as you keep on adding, right, every single time, you're going to be adding on new terms, and we're going to add forever and ever without stopping. That there's no way to add all that up, that it's just going to add up to something that's infinitely large. Well, actually, that's not always the case. And we'll look into tomorrow in class why that might be sometimes the case. And I might be thinking, what if I had a geometric series that also started with 1, but let's say I was multiplying by 2 rather than a half. So 1 times 2 would be 2, and if I multiply that by 2, I'd get 4. Multiply that by 2, I get 8. Multiply that by 2, I get 16, etc., etc. Now clearly here, if I keep on adding these up and they're getting larger and larger, that will in fact add up to something that doesn't have any bound to it. It would be infinitely large, and there would be no way to add that together. There would be just no sum. Now the key here is, though, the common ratio in this problem, in that second one, was 2, whereas here the common ratio is a half. And so therein lies kind of the trick. If the common ratio is correct, we can actually find the sum. If it's not, we cannot. Basically, the rule is this. If the absolute value of your common ratio is less than 1, we can find the sum. So we can find the sum. However, if the absolute value of the common ratio is larger than or equal to 1, there is no sum. Okay, so this is what the formula is if the absolute value of r, or the common ratio, is less than 1. The sum is just equal to the first term, a sub 1, over 1 minus the common ratio. So this is the major formula for this section. Let me show you how to apply it in a couple of examples. Example 1, let's just have a few different parts here. They're all really the same thing. If I were adding up the infinite series starting with 1 to infinity of 5 times 0.8 to the I minus 1, we can actually do this. And the reason is, if you look at, this is where our ratio is, right? Our common ratio is 0.8, and since that's less than 1, we're in business. We can actually find the infinite sum for this geometric series. Now remember, this is our first term, right? This is a sub 1. Just in case you forgot, for any geometric series, it's of the form a sub 1 times r to the n minus 1 power. So I'm just kind of comparing this formula here to here, and I know my first term, a sub 1, is 5, and my common ratio is 0.8. So if I use my series formula for an infinite geometric series, I get my first term, a sub 1 is 5, over 1 minus the common ratio, 0.8. So that's just going to be 5 over 0.2, and if you divide those, you get 25. So oddly enough, if you were to add all these numbers together, even though it's infinitely long and it goes on forever, it would add up to the number 25. Let's look at another example. Part B. Let's say I gave you this one. 1 plus negative 3/4 plus 9/16 plus negative 27 over 64 plus, etc., etc. Let's see if we can find this. Well, we know our first term is 1, so that's part of the formula. The common ratio is what we have to find. So if you recall, what we can do to get the common ratio is divide consecutive terms. I'm going to divide negative 3/4 by 1, and that's just negative 3/4. And if you take a look at that, it does make sense. If I multiply this term, the second term, by 3/4, 3 times 3 becomes 9, 4 times 4 becomes 16. If you multiply this by negative 3/4, you'd get negative 27 over 64. So this is our common ratio, which the absolute value of is less than 1. So we're always looking for the common ratio to be some absolute value that is less than 1, so that we can use the formula. So here the formula is going to be our first term, which is just 1, over 1 minus the common ratio, which is negative 3 over 4. So with a little simplification, that's really 1 over 1 plus 3 over 4. And hopefully we can add these together. If we got a common denominator of 4, that'd be 4 times 1 over 4 times 1. That'd really be 1 over 4 plus 3 is 7, and the common denominator is 4. What I'm going to do here is multiply 1 by the reciprocal. 1 times the reciprocal of 7/4 is 4/7. So that would just give me a sum of 4/7 for that one. Let's look into one final problem, and then we'll call it a video. Let's say this is our series. Let's say I was doing 1 minus 3 plus 9 minus 27, etc., etc., etc. Now here, first term is once again 1. Now our common ratio is going to be negative 3 over 1, which is just negative 3. Basically, what I'm doing to get from one term to the next is multiplying by negative 3, right? It should make sense. If I multiply this by negative 3, I'm getting positive 9. If I multiply positive 9 by negative 3, I'm getting negative 27, etc., etc. Now the problem here is the absolute value of negative 3 is bigger than or equal to 1. It's 3, right? 3 is bigger than or equal to 1, so we cannot use the formula S is a sub 1 over 1 minus R. That only works if the absolute value is less than 1, so we can't use this. There is no sum for this one. I would like you guys to try the following problems on the self-quiz. So I want you to find the sum for each of these. Let's see, for number 1, find the sum from n equals 1 to infinity of negative 1/2 to the n minus 1 power. See if we can do that one. For number 2, find the sum from n equals 1 to infinity of 3 times 5/4 to the n minus 1. And the third one I'd like you to try goes like this. Let's actually write out the sum. It's going to be 3 plus 3/4 plus 3/16 plus 3/64 plus etc., etc., etc. So give those a shot. Remember to check out the common ratio R. Make sure that it's less than 1. The absolute value of R is less than 1. And if it is, use the formula. If it's not, remember, there's no sum. Good luck. We'll talk about it in our next class. Thanks for watching.